Kuwait, a small country with big aspirations. As it enters the new era of the Kuwait 2035 vision, Kuwait is faced with new and emerging challenges in different sectors. The Kuwait Institute for Scientific Research is mandated to identify solutions for such emerging challenges, in line with the strategic development goals in sustaining economic growth based on technological inventions and the creation of a knowledge-based economy. Radioactive materials such as polonium can be found in marine organisms and thus can transfer in marine food chains and cause diseases such as cancer. Therefore, determining the polonium concentration in the environment is important for undertaking radiological safety and risk assessments. At KISA, we have invented a new design for measuring the levels of polonium. Our design consists of a unique fitting that can fit the sample beaker and keep the disc at a fixed position so that it is continuously exposed to sample and coated at one side only. This leads to much higher activity on one side, and time is reduced for analysis, as well as the other side of the planchet can be used in another sample. This can be a cost saving as well. Fossil fuel-driven cars are responsible for 40% of carbon dioxide emission. Currently, the worldwide demand is to reduce CO2 emission by 40% by 2040. Polymer electrolyte membrane fuel cells, PEMFC, are used to store energy and generate clean combustion electrical energy utilizing clean fuels like hydrogen and methanol that can be used for electrical cars. At KISA, we have developed a nano-composite polyelectrolyte membrane for hydrogen and methanol fuel cell applications. The PEM prepared is cost-effective and provides good mechanical strength and thermal stability, as well as good membrane durability and high proton conductivity. The invention can be used in transportation and power distribution. In Kuwait, the crude oil produced is considered a heavy crude oil with relatively high concentrations of metals and sulfur, thus making it difficult for refineries to process. Therefore, hydro-processing is the most flexible process to treat poor quality feed and produce selective yield of product if the catalyst is designed adequately. At KISA, we have synthesized large pore hydrometallization FEMO catalyst using alumina and carbon as support. The invention provides efficient catalytic activities and stable catalyst, with time on stream using heavy crude oil as a feedstock. The catalysts have a high metal retention capacity and superior catalytic stability, using the maximum amount of metals and asphaltene in the feed. In oil refineries, due to the high value market demand, it is significant to optimize the distillate products from crude oil or its residues. Therefore, this invention relates to the development of mild hydrocracking catalysts for residue hydrotreatment that can selectively enhance the catalytic hydrocracking activity to improve the middle distillate diesel yield. The development of a supported catalyst is a balance between the acidic and hydrogenation functions, along with the optimum textural property. The heavy molecules present in crude oil reduce the hydropurification efficiency of the refining processes, as well as increase the environmental emissions of toxic compounds. At KISA, a method for preparing nano-sized sulfide catalysts below 100 mm, was invented throughout the reaction of an aqueous nanoemulsion water in oil with an oil fraction. The method can minimize the adverse effect of the heavy molecules, increasing the production of clean fuels and reducing the overall processing cost compared to the traditional process scheme. In the industry, stress corrosion cracking is considered one of the most dangerous forms of failures. Therefore, it is important to test precisely the capability of materials to stress corrosion cracking. The invention is a new fatigue cracking machine that is used for generating a fatigue crack in the circumferential notched tensile specimen in order to perform a stress corrosion cracking test. The fatigue cracking of the CNT specimens is achieved by subjecting it to simultaneous bending and rotation mechanism. This new invention provides a more accurate monitoring of the initiation and propagation of the crack than other equivalent machines. Boron in seawater presents a significant challenge for water treatment systems, since commercially used nanofiltration membranes are not suitable for boron rejection. Additionally, boron varies in the range of 3.5 to 5 ppm in seawater. However, according to the World Health Organization, boron concentrations should not exceed 0.5 ppm in potable water. The innovation we invented is a thin-film nanocomposite nanofiltration membrane, which includes an ultrafiltration support membrane coated with a trimesic acid coating layer, and it is self-assembled from a liquid-to-liquid interface. The NF membrane showed more than the 50% rejection towards boron and is highest compared to any commercial NF membrane. Furthermore, it showed high rejection towards other seawater constituents, as well as high selectivity to monovalent ions. In Kuwait, we rely on seawater desalinization for domestic and potable use. However, the seawater chemistry of the Arabian Gulf is stringent, with high salinity and turbidity, which requires intensive pre-treatment before desalination. As a result, we invented an integrated system and method for pre-treatment turbid seawater. The system consists of polyelectrolyte injection as a coagulant, followed by clarifier tanks, decanter centrifuge, and microfiltration system for enhancing seawater quality for thermal and membrane desalination processes. The system is capable in enhancing the quality of high turbid seawater and/or any type of water by over 99%. Oil drilling operation produces high saline water. Such water cannot be discharged into the ocean or used directly. Desalination offers a good solution to this problem, but available technologies that can process such high salinity are limited, complex, and energy intensive. This invention is a method and process that integrates two membrane systems, one for desalting seawater using reverse osmosis (RO) system, and the other is for generating energy while diluting the high salinity water using pressure retarded osmosis (PRO) system. The final output of the integrated RO-PRO process is a potable water stream suitable for all uses with no restriction, and wastewater streams suitable for safe direct discharge into the sea, with the possibility of having a portion with zero sulfate content, suitable for re-injection into oil wells for pressure maintenance, all with the minimum or no energy consumption. KISA is devoted to leveraging its state-of-the-art technologies and innovations through commercialization and transfer in support of a diverse economy. At KISA, we are proud of our long history of scientific research and inventions, achieved working hand in hand with the different public and private sectors in pursuit of sustainable growth in today's technological advancement global society.